Nah, it's just me, bro. It's just me.
Alright. Recording started.
Stefan, you're not even in the realm. What are you talking about?
Alright.
Oh, you guys actually buy realms? What is this?
Oh my god. Bruh.
Look, Nathan, just because
They're
you have a
so-
server doesn't mean everyone does.
Alright, you know what? Fair enough. Fair
Thomas
enough.
bought the round.
That makes sense. Thomas is tryhard.
Yeah, that's fair.
Anyone surprised by the fact that Thomas is tryhard? I'm pretty sure no one is.
Alright, I'm gonna start mentioning everyone.
Alright, I have to do the standard. Whoops, that's way too small. Hang on. Let me zoom in more.
Remember, you also gotta stream it.
Yeah, hang on. I gotta do the standard smiley face. There we go.
Oh yeah, it's with the physics behind the smiley face.
No, that's not, dude. That's just a graph of the gravitational potential energy of a pendulum.
Yeah, I forgot about that. My bad.
It's said in chat, Neil owns like every shop.
Literally.
Oh,
Like I think there's one which I haven't done. And it's that tiny gravel one that's 2 blocks long.
Hey, Neil, are the FBLA events online?
Stefan's mic like ear raping.
Probably.
Is Stefan's mic ear raping for anyone else? Or is that just
Hold up.
me?
No.
Yeah.
No, you're amazing.
alright. Sarah's here this time. I see that much.
Sarah's not late. Impossible. I thought she'd be sleeping.
Who else was, Rashab isn't here yet. Did you say Rashab was, AFK in the other call?
Let me ask him.
Who was here last time? Alan was here last time. Oh, there's Rashab.
There's
Axe.
Alright,
didn't say anything about me being unmuted, so
Tutoring
it's okay.
session starts now. Why wouldn't you just say that in the physics channel?
is it announced?
Oh, okay.
No.
Yeah, it's talking to Neil. It's talking to Neil. Neil posted something.
Whatever, Neil. It's your server, technically.
Not technically, it
What
is
do you mean
just.
technically it is?
No, technically.
There's no technically.
Technically.
Technically, it's your mom's server.
Oh, well.
Bro,
God,
Rajiv shouldn't have managing firms.
Yeah, okay, it is your server, but we all have the same. Well, not all of us. But
Rajiv should not have managing firms.
the most active people on the server all have the
He
same
should
firm.
not.
At Molester, my PC. Wait, why did I get added?
I will now proceed to ban
Oh, the
Thayhon.
ban
Why are
Thayhon.
you
Let's
ban-
go.
What?
What is
Yeah,
going on?
why
here?
does Rajiv have managing firms?
Why are
Sorry,
you banning
everyone's
me?
talking about the. Guys, shut up. Okay.
Alright, I'm assuming we start relatively soon.
All
Did
Rajiv
you already
does is just
start?
remove my firms.
They record that massive.
What's wrong with that? Oh no. Guys, it's almost like, someone's gonna listen to that and judge us for being, off top. I don't know.
Okay, Lana's here.
Hey, Thayhon.
No, you.
The power. Oh no.
I don't
I was
know.
gonna say the mouth on that smiley face shows the average total cost curve.
Dude. Yeah, but then it would
Yeah.
have to be, like, sloping less on the.
Oh wait, but we forgot about marginal rep in it.
Well, average cost only works if there's if it intersects the marginal cost at the
Alright.
lowest point.
Alright, are we waiting for anyone else or are we ready to go?
Also, look at the right eye.
Can you write good on a?
Oh.
Are you using a mouse or a digital blackboard?
Why are you making me look like?
He's got a
Ow.
tablet. I only have a mouse.
Oh,
so I'm
okay.
writing too much, but
Alright, are we ready?
Writing on a mouse is so hard.
Are we
I say
ready?
we can start.
Alright, double check the recording starts this time.
I've already started it.
Cool. Alright, so last time we talked about a couple things. We talked about vectors and scalars. We talked about displacement versus distance. We did some one-dimensional motion, and we did position time graphs. So, quick review. Can anyone tell me what is the difference between a vector and a scalar?
Vector has direction.
Scalar doesn't.
A vector is just a different type of number, and it can't be like.
Vector has direction, scalar doesn't have
Yeah.
direction.
Yeah, so a vector has magnitude and direction, a scalar just has magnitude. So a scalar is essentially just a number, and then a magnitude is like a number, but it's going somewhere.
Yeah,
Wow.
I would stay away from calling a vector a different type of number though, because that's not really true, especially as you get into like
100%.
linear algebra. No, they're not. It's not a different type of number. But anyway, we're not gonna deal with that. Can anyone tell me the difference between distance and displacement?
Distance is a scalar, so it's only like
Yeah.
doesn't have direction. It's just like point A to point B. How far is it? And then displacement has a direction. So it's just distance with a direction.
That's very well said. And then, so position time graphs. What pieces of information can we get from looking at a position time graph, where displacement is on the y-axis and time is on the x-axis?
Position, time, velocity.
And acceleration. No, not acceleration. Not acceleration.
The
That's
speed.
velocity time graph.
Yeah, as far as we're concerned, not
Average
acceleration. Yes, you can get average speed, you can get average velocity, you can get displacement at any point in time. How would you get the average velocity over a time interval if you're looking at a position time graph?
Slope.
Alan, am I forgetting anything, or is that
no,
all?
that's all the really important things.
All right, cool. So, let me move away from the smiley face.
Whoa.
All right, so here we have a different type of graph, which is a velocity time graph. Just like we did with position time graphs, let's see what are the different things we can get from this graph. So does anyone know what the slope of this graph would be?
Acceleration.
Okay. And that's one of the main things. And so do you have any idea, or can you explain why that's the acceleration?
Because acceleration is just velocity over time, right? So the y-axis is velocity and the x-axis is time. So
The important thing to note is that
Be
it's a
that-
change in velocity over time.
yeah,
Yep.
change velocity.
And so overall, just to talk a little bit about acceleration, because I realized we didn't actually talk about that last time. So like Alan said, acceleration is change in velocity over time. And so that, if you were to do the units, you'll see is measured in meter. Oops, that's not mem. Meters per second squared, which is another way to think of that is, of course, meters per second, right? So when you think about acceleration, you're thinking about how much velocity in meters per second does it change per second. Does that make sense to you guys?
Yeah.
So if you think about a car, and a car was accelerating 20 kilometers per second squared, right? If you look at its speedometer, right? After the first second, what would the speedometer read if it was accelerating at 20 kilometers per second squared? And anyone should take a while to guess.
What's the question again?
So if we had a car, don't do that. All right, so if we had a car and its acceleration, if I could write, if its acceleration is equal to 20, whoever just did that, don't do that, 20 kilometers per second squared, what would its velocity be after 1 second? Or if after 1 second, what would its speedometer read?
20.
20 kilometers per second.
Yeah.
Correct. Yeah, right. So if you think about sort of this in terms of speedometer, and it starts off at 0, right? So after 1 second, it's going to increase by the acceleration, 20 kilometers per second. After another second, it's going to increase by another 20 kilometers per second, and so on, right? So if you think that's another good way to think about acceleration, is just how many, like I said before, how much velocity it's changing per second. Okay, so then now going back to the graph, can anyone think of a way we can get acceleration from this graph?
We already covered that one, Nathan. the slope.
Oh wait, sorry, my bad.
Do you mean displacement?
I meant displacement. Yes. So first of all, actually ignoring that graph. Let me go down. All right. So if we had a change in velocity, or just from velocity, how can we get displacement? If it was a constant velocity, how can we get displacement?
Wouldn't it be a straight line based on the number of based on the x values?
Yeah. So more looking into the equation. So if I said a car was moving with a velocity of 5 meters per second for 3 seconds, how much distance did it cover? Can anyone see if you can figure that out?
Wouldn't it be the final distance minus the initial distance?
How would you get those values?
Oh yeah.
All right, so let's look. The one way to look at this is dimensional analysis, right? So if we just looked, there's seconds on the bottom here, and if you just imagine this over 1, there's seconds on the top, right? Our final answer is in meters because we're looking for a displacement, right? So we want to cancel out seconds, meaning we have to multiply them, because then this will be on the top, this will be on the bottom, they would cancel out, right? So in general, the displacement is equal to velocity times time. And obviously this only works when velocity is constant. Everyone with me so far?
Yeah.
So in the above example, if something was moving at 5 meters per second for 3 seconds, its final displacement would be 15 meters. You just multiply the velocity times the time it took. And if we graph that out, if I stop doing that.
Oh, that's a nice graph.
Made a nice infinity sign list.
You gotta make it Khan Academy style, and you gotta say, "Hold on, let me just change this color." That's better. That's how you go. That's how you go.
I mean, I'm literally dealing with like a random. This is actually a Nook. Why is it deleting that? All right, you know what? Whatever. We're just gonna.
It's a
move
really
down.
nice infinity sign, though.
All right, we're just gonna pretend that didn't happen. So, if we look at this graph, okay, and this is the same thing we're talking about before. So this is 5 here. That would be 0, 0, and this is 3. And I said that it was just moving at 5 meters per second for 3 seconds, right? Just looking at this graph, don't think about just multiplying the two. Looking like we said, we could get acceleration from this graph as the slope, and obviously it's 0 because it's a horizontal line. But where can we get displacement from this graph? Anyone try and guess?
So since we know velocity, and velocity is just displacement over time, can we just multiply the velocity times time?
Yes, if you were doing that, that would work. But what does multiplying those two axes represent on a graph? Just like how if you took velocity over time, that would represent the slope, right? Does anyone know what multiplying the two represents?
If we look at another way to look at this is if we just think of the two numbers as remove the fact that they're velocity and time per second. If we look at this as just a graph, and you say, okay, you need to multiply these two numbers together to find some value. If you're multiplying them together, what kind of shape would that make? Or like what kind of values would you get from it? It's kind of counterintuitive, but
All right, let's see if we can sort of bring that. So imagine I draw this square or this rectangle, and I said that this rectangle is 5 tall and 3 wide. What is 5 times 3? Obviously it's 15, but what does it represent in terms of the square?
Area.
Area, yes. So stop doing that, tablet. Okay, so what that represents is the area under the graph. So in this case, when you're looking at a velocity versus time graph, the acceleration, or not the acceleration, I am stupid. The displacement is the area under the graph. Everyone following so far?
Yeah.
Yeah.
All right. So now I'm gonna shoot this tablet at some point. All right. So now let's go back to our original graph. Okay. Same concept here, right? Obviously, we know acceleration is going to be the slope, and so we'd say rise for run 6 and you could do 2 over 3 for the acceleration, right? But displacement is going to be the area under the graph, or this portion here, right? So can anyone, just looking at it, think back to geometry. How would you get the area under the graph here?
1/2 base times height.
Correct. Does anyone recognize that equation from anywhere in physics?
Please tell me. Please tell me you can at least think of something that has the same general structure.
Oh, a ramp.
All right, you know what? We're gonna build to that later.
Yeah,
I mean,
what was that
you know,
like?
a ramp does technically have the
Well,
same.
Yeah,
I mean,
a ramp is
fair
a
enough.
triangle.
We're talking
Fair
about
enough, you're
numerical
not
structure
wrong.
here.
You're not wrong. Okay, but anyway, so the important so the important thing to note here is that the displacement of when you're looking at a graph is going to be the area of the graph. So it's going to be the it sort of depends on the shape, but obviously in this case, since we have a linear acceleration or a constant acceleration, it's going to be 1/2 velocity times time. So now we're going to go one step up, and we're going to talk about. Wow, I made so many lines on this thing. Can I erase this? There we go. Cool. All right. So now we're going to talk about acceleration time graphs. Okay. So just imagine here, like in the previous graph example, it was 2 over 3. So over here is 2 over 3, and I don't remember how long it was. It was 6 seconds. So this is the graph of acceleration, right? So from this graph, again, how can we get velocity?
Wait, how is it the graphic? So can you start at a high acceleration? Don't you have to start from 0?
No.
mean-
Well, in the real world, technically yes, but as far as AP is concerned, no. Because you can say an object starts at a velocity of 0 and reaches a velocity of 10 in 2 seconds, and it's accelerating constantly throughout that whole time.
Okay.
Right.
So this would be a valid graph you could see on a test, for example. So what would the velocity be looking at this graph, and what would the final velocity be rather from this graph, and what does that represent visually?
Does this graph?
Say the question again.
4 meters per second.
Yeah,
Yes. And so what does that represent visually?
the area.
The area of
like
the rectangle.
the area under the graph here.
Oh.
So again, that's important to sort of recognize the relationships between these three graphs and how the slopes and areas under these graphs sort of relate to each other.
Right. It's important to realize that for, acceleration is to velocity what velocity is to displacement. They have the same relationships to each other, if that makes sense.
So now here's the thing. If I said I wanted to get final velocity, if obviously you said looking at the graph, you multiplied this value times this value, right? So we could say that getting a change in velocity is equal to acceleration times time. Does that make sense to everyone so far?
You have to slow down a little bit, Nathan.
Oh, whoops. There you go. Change.
So-
I didn't put a V. Change in
Change
velocity.
in velocity equals acceleration times time.
Yes. Does that make sense to everyone how we got that from the graph?
Yeah, I get that.
Okay, is there
Yes.
anyone who that doesn't make sense to?
It's just the same thing how you got the other thing too, right? The velocity graph.
Right.
Yep. And so what I wanted to relate to with this is that is where this first equation in the AP Physics, the formula guide comes from. So this obviously is final velocity. This is initial velocity. So this is the same as just replacing this whole part with change in velocity is equal to acceleration times time. Okay. And then, let me not do that. To talk about where that that second equation comes from. Actually, do I want to do that right now? Let me look at the plan. No, we'll talk about that later. Okay, so now we're going to do Unless Alan has anything else to say. Alan, do you have anything else to say?
Not much other than the fact that if you can understand the relationship between displacement velocity and velocity and acceleration, it makes it far easier to solve like kinematics problems, because you can understand how an interaction or a change somewhere will create like the magnitude of the change it will create somewhere else, which is really important.
Okay, so if anyone has any questions, obviously you can unmute and ask at any time. But if you could go ahead, if we could get back into the question thingy. The link is on the screen. And we're going to answer some questions. Also, I will put the link in general as well to make it easy.
We'll have to start setting a shorter time period for the questions, though, because last time we spent too long answering questions. So,
How many people do we have?
how many people do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 or 11. I don't know, I lost count. That's not that important.
You lost count at 10.
Hey, shh!
Okay.
Yeah, it's
All
10.
right.
It's 10.
All right, cool.
So I think maybe having it be what, like 2 minutes to answer each question?
I mean, it sort of depends on the question. I think we should do it where after half people have responded, a minute left.
Cool. So you have like, who took? Okay. I'm also gonna note again that please don't take away your results after you put them down, because if they're your final answer, we want to know what your final answer was. Don't change them. That doesn't help anyone. Your name isn't seen. No one knows it's you. No one knows anything like that. It just shows us like basically how many people would have gotten it right and how many people would have gotten it wrong.
All right, we locked it. So, the correct answer is acceleration. So the reason why direction of motion is not necessarily correct is because you can be given a graph without being told what direction positive is. If you were told, positive is to the left, then yes, you could tell direction of motion, but that's not necessarily inherent to a velocity versus time graph. And so again, can anyone just remind me, what is acceleration on a velocity versus time graph?
Slope.
Yep. Anyone have any questions about this one? Okay. Oh yeah, right. For this one, if the graph is a little hard to see where the numbers are, I will put a thing. Where is it? This one. I'll put this in general. So this one sort of, just while you guys are trying to figure it out, I'll say some things. This one sort of combines things that we talked about before. Just remember, for displacement, you can split this up into two triangles, one at the beginning, one at the end, and one rectangle. So that's how you're going to try and get displacement.
What's the formula for the area of trapezoid again?
I would just split it up into two triangles and a rectangle.
Yeah, it's typically easier than trying to remember any kind of formulas.
Technically, there is a trapezoid formula, I believe, on the formula sheet. But
Isn't
you're
it like you take
It's like base 1 plus base 2 over height or something.
yeah,
But
you're gonna have a lot easier time splitting it up into two triangles and a rectangle.
it's
Just adding them together.
It's the first base plus the second base divided by 2 times the height. Used
yeah,
for
it's
the trap.
it's taking the average of the okay. It's like taking the average of two rectangles made out of the same made of just those bases.
What is that?
Mine.
dang, bro, she's hungry.
No,
Oh,
he wants to just sit on my lap. Why did I just call my own cat a she? Am I really that stupid?
Come on, Nathan.
My cat would never do that. She only meows if she wants food. She's only nice if she wants food.
Nah, he just wants to sit on my lap at all times. Like literally, I'll be in the middle of taking a test, and I'll be like, "No, lap now."
Yeah, no, she's either
It's called
hunting.
priorities.
She's either like looking out the window trying to hunt birds from the other side of the class, or trying to be nice to me so that she can eat.
Alright,
Or sometimes she's actually nice.
I'm gonna say 1 minute left on the problem here.
Okay. Just pick your best guess.
Yeah.
So if you have net displacement, pick one of the ones that has your net displacement. If you found average velocity first, then A, you're a maniac, and B, pick one of the ones that has your correct your answer in it.
It's just kind of hard to like tell what the values are supposed to be.
Then look in general chat. Maybe I didn't make that clear, but if you look in general chat, I posted the thing that explains it.
Oh, but
All right, well, here we'll give a little bit longer now that
no,
makes
it's okay.
everyone
It's
clear.
okay. I already picked one.
Okay. I think Alan, should we lock it or just leave it for a minute?
Until it's 29.
Okay. All right, now
You should give him some attention.
he was just on my lap, but I can't like use anything. One of these, he's on my lap.
Alright, yeah, you can close it now, Nathan. Oh, good, 10 responses.
No.
Whatever, just hit responses, and if somebody changes their answers as we're looking at them, you're dead to me. That's about it.
There, we locked it. All right. So good, the majority of you did get the right answer. So let's talk about this one. So anyone who did get that right answer, how do you get the net displacement?
Someone who hasn't spoken a lot already.
So you just find the area of the trapezoid by doing what you guys said, splitting into two triangles and a rectangle. So you can do the first triangle on the left, which is 1/2 base times height, so 1/2 times 3 times 3. And then you can do the second triangle, same formula, 1/2 times 5 times 3. And then rectangle is just base times height, so 15 times 3, so 45. and then you do math and add them, and you get
Yep.
57.
Yep, very good. Does anyone have any questions about how to get net displacement from velocity time graphs here? Okay. So average velocity was a little bit trickier, I'll admit, because you had to sort of think about it. But how did you guys get average velocity?
I
Anyone who got it
divided
right?
the I divided the net displacement by the change in time.
Yep. So that is a quantity that you can technically get from the graph, but you have to sort of go get the displacement first and then divide it by the time. Just like in general, any displacement over time is average velocity over that time period. So that's
I
where you
just
get
guessed,
average
and it
velocity
was the
from.
one in the middle.
Nice.
Because 2.48, I don't know.
So does anyone have any questions about how we got average velocity there? Okay. Let's move on to this one. So this one is very similar to an AP question that was in 2018, just slightly changed. So this is a very good example of an AP test multiple choice question. All right, more than half have answered, so we'll give it a minute left. All right, everyone's answered. Probably not gonna let me lock. I need to fix that. There we go. All right, good. Most Bangle, come on. All right, so most of you got that right. So anyone who did get it right, can you explain why you arrived at that answer?
The initial velocity has a greater slope, and then it starts to like become less steep, which is why it's smaller in magnitude, I guess.
Yep. So remember that. So it's positive throughout because obviously, if you take the slope at any given point, so like the slope here would be the line that would go stretch off like this. The slope here would be like this, and so on. Is always either positive or really close to zero over here. It's going upward. So we can say it's obviously one of the two positive answers. And if you just look at the slope between 40 and 70 here, right? 70 being here and 40 being here, and you were to draw a line, you can see its slope is fairly close to zero. Whereas if you look at the initial acceleration, which would be the slope here, you can see it's much greater. So this is just a sort of, you have to look at the graph and remember that, the slope at any point of the velocity time graph is the acceleration. So the acceleration decreased as time went on. Does anyone have any questions about that question? Okay, cool. Hopefully this one's easy. Do we still have 10 people, by the way?
Let me just do another count. Yeah, it's still 10.
Alright. Alright, just a little bit. Alright, cool. I don't need to lock it. Alright, so it's displacement. And so again, this is just something you're going to have to either memorize or look at your equation sheet. Velocity times time, anywhere, is displacement. And again, if you remember, meters over seconds times seconds, seconds cancel it, you get meters, which is going to be a displacement. So just make sure you sort of, memorize that the area under a graph of velocity time, or just velocity times time, is displacement. I'm actually surprised no one changed their answers. That's a shock.
That's good. Alright. Give you 1 minute more. Alright.
Okay. So, yep, 75. So, 150 was sort of the trick one in there, because that was a very easy answer to get if you weren't reading the question carefully. Anyone who got 75, do you want to explain how you got to that answer?
So it says constant acceleration, therefore it's just the slope is just constant. It goes just diagonally straight. It says it went 10 meters a second, which would be the velocity, 15 seconds, which would be the time. And that makes the area underneath is the net would be the net displacement. So all I have to do is calculate area by doing 1/2 times 10 times 15, which gives you 75.
Yep. And so if you just, again, sort of imagine that graph in your mind, you would think about, it starting at 0, straight line to 10 after 15 seconds. And just like you said, 1/2 velocity times time would be the area under the graph. So 1/2 10 times 15. Okay.
Nice.
So I believe, yes, that is the end of this one. Nope, don't see those. Actually, I'd probably put it to a worse screen. You know what? That's fine. Where's the other one? There it is. All right, here we are. Okay, so now we're going to talk a little bit about the kinematic formulas.
Man, someone really wants to call you right now.
Yeah, I don't understand what this is. It's a random number. I don't know who this is.
Well, they clearly don't understand the beauty of physics, so, that's fine. Alright, so, from the formula sheet, there are 3 main kinematics formulas, which are.
Why? What
like-
is this?
Can you not just like block them?
Your cat's just resorted to other measures. That's all.
Clearly. Alright, Henley, let's put my phone on Do Not Disturb.
Alright, so you have 3 main kinematic formulas, and they are. I'm gonna try to write this with a mouse, and it's gonna suck, but it's gonna be fine. So we're gonna have change in x is equal to VOT
I gotta go Do Not Disturb. Okay, hang on.
plus 1/2 AT squared. I hope that's probably not at all legible, and the V just straight up isn't appearing. I swear I drew one right here. Okay, there you go. So you got VOT plus. Should I make my T actually look like a T? That would help. That's just making it worse. Alright, my handwriting's bad anyways. So you have your 1/2. You have a VOT plus 1/2 AT squared, and then there's the other one, which is the area, which is I have to pull it up and look at it because I don't have it up right now. 1 second. Should be in. Yep. Alright. So. There's that one. Then you have the. Oh god. This is from I remember. Whatever. Okay. Yeah, the other one is V of x. I don't know why they're using the notation of V of x, but V of x is equal to Vx naught plus a x t, which is from the area under the velocity graph, which is of course a times t, and then plus your initial velocity. And then there's the weird one, which is Vx squared equals Vx naught squared plus 2a change in displacement. So the first one is from the area under an acceleration graph, which is how you get, of course, the VOT. And then it doesn't, for the people who are really, really good at math and probably don't need to, probably wouldn't be here, this is actually an integration, a double integration of the acceleration graph. But of course, it's not really, if you know math, then that's pretty cool. But if you don't know math, then it's just, you multiply these, multiply those, and you get your answer. The second one is the area under the velocity graph, and the third one is weird. And it
the third one's not as important to go over where it comes from, but it is a useful equation.
Right. Specifically because it doesn't take in time.
Alright, the moral of the lesson is these are the 3 main kinematic equations you're going to use to solve kinematic problems. And those are the first 3 in your formula sheet. And Sarah, he is okay. He's like literally, I have to put him on my lap, and then he stops. Now he's on my lap, and now he stops.
Alright.
I don't know if you can hear his purring, but anyway. So, yeah. Any questions about that? I wasn't really there for that because my phone, this person kept calling my phone. I don't know what it is.
So, are you saying that, like, if you want to find how do you know which one to use when? It's like, honestly, he never really, like, I might have zoned out or something, but I never really understood.
He just said to use it like, he just, in
Yeah.
class, he just said to like, use it to different ones depending on what givens you have.
I mean, it's gonna sound bad, but that's pretty much it. You want to use the equation that has all but one of the variables that you have, basically. Because if you're solving, you want to only have one equation, and you want to solve that one equation. And in order to solve one equation, you need to have only one unknown. So, for example, if you're trying to find time, you obviously can't use the last one because it doesn't even have time in it. But if you are given displacement but not velocity, then you would use the first one because the first one has displacement but not velocity. If you were given velocity, you'd use the second one because the first one doesn't take in velocity. And it's just that kind of stuff. Seeing what variables you're given, and then what you can plug into the equation, and making sure that you only have one unknown. Because if you have more than that, you can't solve it. And we're going to do some practice problems now as well.
Okay. So yeah, like Alan was saying, you just kind of gotta look at that, and like the best way to figure out which equation or to get better at figuring out which equation to do is just look at a ton of problems and try and figure it out. So let's start with a relatively easy one. So we have an object. Say it's a rock, and this rock is dropped, and it takes 3 seconds to hit the ground. Okay, and so we're gonna ask how long or how far did it fall, if it took 3 seconds to hit the ground.
Right, and before we do anything, we need to figure out what things do we know. What variables can we get just from that one statement of we dropped the rock, basically, and it takes 3 seconds to hit the ground.
We know acceleration and time.
Which are what? Of course, the time is 3 seconds. What's the acceleration?
Negative 9.8.
So for physics, at least for our class, you just generalized it to negative 10 meters per second
Yeah,
squared.
all of the AP FRQs and multiple choices will always base their answers off of negative 10.
Okay.
Oh, really?
Mm-hmm.
Yep.
Oh, okay.
Yeah. So what other variables do we know here?
If you use negative 9.8 on the FRQs, you won't be wrong, but on the multiple choice, all of the answers will be using negative 10.
Right. So what other variables do we know here? For example, do we have an initial velocity here?
0?
Right, 0. It's just dropped. Any other? Oh, you go, Nathan.
Go ahead. Continue.
All right. Are there someone who isn't Thehan? Are there any other variables here that are any other variables we don't already have written down for this problem? Anyone? Alright, I'm going to take that as a no. So, with these, given the fact that we have time, we have acceleration, and we have our initial velocity, what of the 3 kinematics equations can we use to solve this? Again, someone who isn't Thehan.
All right, so let's look back at the equations we have up here. So remember, we have acceleration, time, and initial velocity, and we're looking for displacement, right? So we need an equation that has these 4 variables and only these 4 variables, because if it has any more, then we can't do it because we would have more unknowns. So which of these equations has those 4 variables only? Or possibly less than those 4 variables, as long as it has change in x.
We're going to probably have to start, asking people to see if other people are actually understanding it, because that's kind of the point of this. And if you think you know the right answer, but you don't know if you're right, just do us a favor and say it.
Wait, it has to be one of the change in x ones, right?
Right.
So would it
Wouldn't
just
that be the second one?
Yeah, the second one.
Well,
Or-
what are you trying to find here? Trying to find
Actually-
how far it fell, right?
Yeah.
Out of the
change in
order,
displacement.
Oh yeah, the first one actually.
It's the second one on the AP Physics sheet. Second one Alan wrote. I get what you're. Or first one Alan wrote. Second one on the AP Physics sheet.
Yeah.
Wait, I think. Yeah. First one Alan wrote. Second AP Physics. There we go. That's correct. Okay. So yes, because this one has the change in x that we're looking for, and it has the initial velocity which we know, the acceleration which we know, and the time which we know. So this is the equation we can use. Does that make sense so far?
Yes.
Okay. So, pretty much all we got to do is plug it in. So what we're going to do, I'll move down here. There we go. And so we'll say change in x is equal to the initial velocity, which is 0, plus 1/2 -10. What was the time? 3?
3.
3 squared. So someone would go ahead and get out a calculator or mental math, whatever you want, and solve that. Let me know what you get.
-45.
Why is it negative? Do you know?
Well, the first it's going down, but not using the numbers, but since there's a -10. But if you're just looking at the rock itself, it's moving downward.
Right. And that's the important part, understanding why in the scenario why it would be negative. Because if you can look at the numbers and you can say, well, obviously these numbers would mean this. If you were to make a mistake in your math, you wouldn't be able to catch it. Because like, for example, if you forget to put a negative on when you start the problem, then you just wouldn't notice.
Why on the formula sheet does it say x? Like you wrote 0 for the first term, so why is it says x equals x 0? What isn't x the
Right, so
position?
all of that subscript x means, it means the velocity along one axis.
Oh no, he's
So-
talking about if you look at the equation, are you talking about the one where it's x equals x naught?
Yeah.
Yeah.
Why is it x naught?
So x naught is your initial displacement.
Okay, yeah.
So,
So
if,
that
yeah, if
Okay.
you put delta x, then that just shows it's the displacement like over that period, if that makes sense.
So
Yeah,
that you could rewrite this as the final displacement is equal to the initial displacement, which is 0 plus 0 plus, 1/2 at squared. But all we did is we just moved, you essentially subtract the initial displacement x naught from both sides, and that's, final minus initial, which is change in x. It was you just simplified it because there was no reason to add another 0. Anyone confused about that?
Alright, so, from this same problem, what would the rock's velocity be when it hits the ground? So we have the same variables.
0.
Okay, so in physics, whenever you're talking about something hitting the ground, they always mean just before it hits the ground, basically. Because technically, yes, when the rock hits the ground, it's not moving anymore. So here we have a change in displacement, we have a initial velocity, we have an acceleration, we have a time. What equation could we use to solve those? To solve for final velocity.
X.
There's the b squared equals the initial velocity squared plus 2a change in x. That one works.
Yep, that is one equation. Does anyone see another equation that would also work?
The
Technically, there are
first
two.
one on the sheet.
That one also.
Yep.
That also works.
So they would both work. However, which one, if you were trying to get the best precise answer, would be better? Can anyone let them know or make a guess?
The one Neil said because it's a change.
Not exactly. So first of all, I don't know who said what, gonna be honest. I don't know your names. But the v squared one involves change in x, right? Which is a value we just found. Whereas the first equation, velocity is equal to initial velocity plus acceleration times time, uses all values that were given in the problem. Right? So in some cases, yes, you'd have to use an equation that plugs in previous values. However, when you have the option of using an equation that uses only variables presented in the problem, especially if you have problems with decimals, you want to go with that one. Because if you end up doing any rounding when solving your previous answer, well, then your new answer is just going to be a little bit more off.
Right. This makes sense to everyone? Anyone have any questions?
Wait, could you explain why it's negative 45 again?
So for this problem, because you're dropping it, like you're dropping the rock, it has a negative acceleration because it's moving down. So then its displacement, because it's moved down, is negative. It all has to do with how you've oriented yourself when you've written the problem, basically. Because technically you can do the problem saying that there's a positive acceleration, and then your displacement would be positive. But typically we frame things around down towards the ground as negative.
Okay.
Alan, did concept board just go down for you?
It was having an issue earlier. Did it? Oh, it may have. That's interesting. That's
All right, fun times.
very convenient. All right.
I mean, we only literally have 4 minutes left, so I'm not sure it's. Yeah.
I
So.
had a private window.
And that's definitely not the problem. I'm also looking at it in another window that is it's just not flat out not working. Okay, so well, let's just talk here. So what we said that the best equation would be the first one on the AP physics sheet, which is final velocity is equal to initial velocity plus acceleration times time. So of those variables, we know initial velocity, which was, anyone tell me if you remember? I know it's gone now.
Initial velocity is 0.
Oh, I can move it still. Okay, yes. Initial velocity is 0. And our acceleration is what?
Negative 9.8 or negative 10.
Yep. And then our time was?
The time is 3 seconds.
Yep. So if we just do negative 10 times 3 plus 0, which is, because obviously...
Did they write it as an F? Or are you writing it as an F or is that a T?
This
For time.
That's a T. Sorry.
Okay. Alright.
But yeah, so you would just do negative 10, Bengal. Sorry. You just do negative 10 times 3, and that would give you your final velocity of negative 30. And again, it is negative because, you know, its velocity is towards the ground, down towards the ground. Anyone have any questions about that? Alright, silence is cool. So,
Is concept board back up or no?
not that I can tell. I don't know, maybe they're doing maintenance or something. Alright, well,
Silent, we're
so-
just listening to the cat.
It just showed that it was for maintenance. I think you just close it.
Oh, wait.
It's down for maintenance. When
Where-
you switch back, like when it went to this page, it said it's down for maintenance.
okay, I didn't spot that, but I trust that was there. Anyway, so, yeah, so on Friday, we will do another, problem like that deals with kinematic formulas. We'll do some conceptual questions for AP stuff, and then we'll get into two-dimensional motion, because all we've been doing so far is one-dimensional motion. So that's that for this session. Alan, do you have anything else to add?
I mean, not really. It just seemed. I just wanted to ask, how quickly are we moving here? Like how I don't remember exactly how big kinematics is. Because it's
It's one-dimensional motion, two-dimensional motion, and that's it.
oh, that's it. Okay, and that's 1/10 of the whole stuff we're gonna be going over. So that's a pretty good pace.
Today he
So-
said that the thing we just finished up was like 25% and waves is like 10.
Yeah, they are different percentages. Physics are in Unit 1, which is, the stuff we're doing right now, is worth 10 to 16% of the test. I don't know the other ones off the top of my head. I just know that one because we were working on it. But yeah, they are worth different percentages. So does anyone here think we're moving way too fast? Are we doing okay? Should we go slower? Should we spend more time on things? Feedback, please.
It's fine.
Yeah, I think it's okay. Good.
It's cool because like we can like derive stuff now because like before we just got the kinematics equations.
The last thing I
So
fully
this kinda helps.
understood, last thing I fully understood was uncertainty, and I don't think I've still fully understood that yet.
I've never understood uncertainty.
Yeah, I only understood it once he did the retest, and he had this like, he was that was the first time I saw him without a mask or whatever. So
Oh yeah, he like did the thing on Saturday in his house, and he
no,
like,
not on Saturday. It was on a Thursday, and I believe someone from this was also taking the retest, and then yeah, and he explained the uncertainty and sig fig.
oh.
Okay.
Well, I gotta go.
That's
See ya.
interesting. Yeah, you guys can go. I'm gonna talk for a second. That's interesting because sig figs is an IB only topic. They will never test you on sig figs in AP.
Right, you can just put 3 sig figs for everything and you'll be fine.
Oh,
Yeah.
we're doing that in pre-IB chemistry too.
Oh
Yeah,
in
chemistry-
chemistry, yes.
Chemistry will, because that's an IB class, right? But in AP physics, they will never ask you for sig figs. That is an IB only topic. So literally, you just put enough decimals that your answer is reasonable, and you'll be fine.
Okay, that's good to know.
Yeah. Uncertainty, they won't test you on. I'm assuming he probably went to the same degree that you need to know in IB. Uncertainty, I'm pretty sure AP can ask you vague questions about it, but nowhere near like the equations you guys had to use with like the.
He just said it was helpful, and that
It is
many
helpful.
college students struggle with it, so it's better you start to know it now. That was the first thing we did, and the second day of school we had a quiz, so we were
Nice.
all kind of like, bruh.
All right, yeah, that's kind of sucks, but yeah, AP will not test you on uncertainty nearly at all like that. You won't. If they ever ask about uncertainty, it will be like qualitative. It won't ever be with numbers.
Yeah, because we had to do a lab or kind of thing where we had to like find the he gave us a couple numbers and we had to find the absolute and relative uncertainties of like for like 2 pages worth of
Oh
information.
yeah, it was a tennis ball thing. We dropped a tennis ball from approximate. We first like dropped it from approximate height, then we used a ruler, and then
Yeah, it sounds like he's just whatever he's doing for the IB class, he's just doing for the AP class because that's something that you have to do in IB. I'm pretty sure it's actually one of the prescribed practicals for IB. So yeah. Oh well, is what it is, I guess. All right. Well, if no one has anything else, y'all can leave. If anyone does have any questions or just anything about whatever you're doing in class right now, feel free to stay and ask. Otherwise, see you.
Alright, bye.
Thank you.
Tell your cat I also
Thank
say
you,
bye.
bye.
Alright,
I
see ya.
will.
Alright, I'm gonna stop recording then.